Okay, sorry, because for this, right, we are finding the minimum reflux. So minimum reflux, there's only one graph. And the graph that you don't really need this yet, because you are finding minimum reflux. This is the reflux. This is for the reflux, when you have the reflux ratio when they give in the paper. Example, this, yeah, see? R equals to 8. This is your reflux. So for this question, we are going to find our minimum reflux. And how do we find minimum reflux? So we're going to do the equation I showed you before regarding the Q. Is y equals to Q over Q minus 1 x minus xf, which is your feed composition, and Q minus 1. Alright, so for keywords for Q, right, there's always three types. The first condition is below bubble point. Okay, below bubble point means the liquid line. This is vapor. This is liquid. Okay, so at this point here, we're gonna say this is the bubble point, and here is the dew point. Here is the bubble point. Alright, so for first condition for Q, finding Q, if fall below bubble point, which is below here, we are going to use this equation called latent heat plus, this is stand for latent heat, this is plus m Cp delta T over your latent heat. Alright, give me a moment to check whether it is correct. Give me a moment. Suddenly forgot. I think should be right. It's gonna be wrong. Okay, now I'll do that in another video for the reality. Okay, for second condition, if it's a saturated vapor, your Q equals to 0. And the third condition, if your Q, if it's they are talking about saturated liquid, your Q equals to 1. Alright, this is because look at this, liquid and vapor. Alright, as you increase your latent heat, your heat capacity, you start to lose heat, so your vapor will be 0 and your liquid is always 1. So as you move up, you lose heat, so your Q equals to 0. This is your dew point, this is your bubble point. Okay. Alright, so for this question, we talk about saturated vapor. So this is the condition. This is the condition that you need to do. So let's do another piece of paper. You know that y equals to q minus 1 xf over q minus 1. If we sub in 0, 0 minus 1, x minus your xf equals to 0.32, 0 minus 1. We do the math, got 0. So y equals to 0, cancel. Y equals to 0.32. So we can assume that your Q line, your Q line will be right here, Y. So you cut through here, and your this distillation, you're gonna cut right through here. So this is what we assume. This is what we're gonna know. But for now, we are not going to do this because this is finding minimum reflux. We are not doing theoretical stages. But for question 3E, we are doing theoretical stages. So with that being said, let's go up to our graph here. 0.32 at y. This is your y. 0.32 is around here. We're going to sketch this across. Give me a minute. So to find your y prime, we'll go back to this equation for the minimal reflux. To find your y prime, you know it's at 0.32 using your Q-line equation. Q-line equation is this. And for your x prime, you're gonna hit down here. Hit down here. Okay. About 0.8. Sorry for my ugly handwriting. Okay, so we can now we know that your y prime equals to 0.32 and your x prime equals to 0.17. Alright, minimum reflux equals to triangle y over triangle x equals to xd minus xy prime xd minus x prime. And so we're gonna start in the numbers. 0.92 minus 0.32, 0.92 minus 0.17. So this is gonna give you so your minimum reflux ratio is 0.8. Hope that helps. We're going to discuss question 3E, where we're going to do the whole distillation question.